Welcome to this detailed overview of CCX for cloud service providers. CCX is a Kubernetes-based DBaaS that helps you give your customers optionality over where their data stack is located. Let's start with an overview of the architecture. Installed on Kubernetes, CCX comes with all the necessary backend services and operators to get you up and running. CCX is based on loosely coupled architecture, which means you can use a different DNS service instead of external DNS. Also, instead of using your Victoria metrics, you can use a different Prometheus-based metrics server. The CMonDB stores metadata about managed data stores, while the CCX DB is responsible for storing CCX metadata. For interfacing, your cloud customers have access to a customized console that can be white-labeled to reflect your branding and your interface preferences. CCX offers a public API, enabling your operations team to easily integrate CCX maintenance, deployment, and lifecycle management into your existing DevOps workflow. The admin panel helps you easily support and manage your end-user DBaaS experience. Grafana is one of the services you can use to create customized dashboards for specific metrics on both the data plane and the control plane. You can integrate CCX with any notification tools you are already using via webhook, Slack, PagerDuty, or email. We currently support AWS, GCP, OpenStack, and VMware infrastructure technologies. These are the databases currently available on CCX, and we are working on supporting more in the future. We all know that backups are critical. With CCX, backups can be streamed to any S3 compatible storage. Let's run through the key features of CCX for CSPs. At the bottom of the screen, you can see an example of a white-labeled front end from one of our Swedish cloud service partners, Elastic's. Additionally, CCX offers automatic repair within the Kubernetes environments. For example, if any pod fails, it is automatically restarted or replaced to ensure that CCX maintains its availability and resilience. CCX provides customizable database settings through its Helm charts to give your users the specific database configurations they need, along with a billing API to streamline your commercial operations. Also, CCX will keep your system updated with the latest security patches throughout its lifecycle, ensuring they remain protected. Now let's run through the key features of CCX for end users. These are the necessary features that the DBaaS end user typically expect. Provisioning and deployment, failover and auto recovery, backups and disaster recovery, scaling up, out, and in, firewall and security, database user management. Typically, multiple users require some level of access to databases. Observability dashboards. These include both system metrics and database metrics. You can also use Grafana to build out specific dashboards for your end user. Plus, they can use query monitoring to see the top queries and connections in a particular database. During the demo, we'll explore some of these features in detail, showcasing how CCX can be customized, extended, and seamlessly integrated with your platform. Anyone can write software to deploy a database, but what happens in day 2? CCX offers automatic repair features, including DNS updates and full lifecycle management. It ensures your system is updated with security patches and notifies you of any issues that require your intervention. You also have the option to apply updates immediately or schedule them for a later time. Additionally, you can securely back up your data through any S3 compatible storage. You can also perform point-in-time recovery. Data updates are executed using a roll-forward algorithm, meaning the oldest replica, or the primary if no replica exists, is selected first. Then a new node with the same specifications is deployed to join the data store. Now let's move on to the demo of installing and setting up CCX for cloud service providers. First, we'll tackle the installation and setup of CCX for CSPs. CCX can be installed in just 3 steps. First, deploy the CCX dependencies. Next, deploy the CCX core services. Finally, deploy the CCX observability stack. All of these can be deployed on Kubernetes. The steps are available in our documentation, and the Helm chart is available on GitHub. We've also added the Helm chart on Artifact Hub for easy access. You can find all the links in the description of this video. This is the CCX documentation. You can go through the comprehensive details here. These are the quick start with AWS instructions. As mentioned, the CCX Helm chart is available on Artifact Hub and on GitHub. It's public, so you can easily test CCX. Now let's go ahead and cover these features: the admin panel, the end user portal, data store deployment options and configurations, and the observability dashboard for monitoring. Note that future demo videos will go into backups, failover, and more features of CCX. Now let's deploy CCX together. We have an empty Kubernetes cluster in the default namespace. Let's create another namespace to deploy our CCX workloads. We'll create a dev namespace with kubectl create ns dev. We need to create an additional namespace because the MySQL operator can't run in the default namespace. Either way, it's best practice to create separate namespaces for each workload when deploying on Kubernetes. This keeps things organized and makes management easier. Then create an alias so we don't have to keep running kubectl. Let's switch context to the dev namespace we've already created. For this demo, we're deploying CCX on AWS. In this case, I need to create a Kubernetes secret to access my AWS account to deploy resources. I have already created a YAML configuration with my AWS credentials that I will apply here. Once that secret is created, we can deploy CCX and its dependencies. I'll add the CCX Helm repository. I've already added this to my configuration files, so I can just run Helm repo update. Now let's install CCX dependencies. You can get the commands from the documentation. This command installs the CCX dependencies. I put it in debug mode so you can see the progress of the installation. CCX dependencies include everything the core services need: NATs for connecting services, external DNS, and an ingress controller, as well as the database operators. Let's run the command. After a few minutes, you'll see that the CCX dependencies are being deployed, and it's creating all necessary resources, pods, and deployments as required. It creates the NATs, the external DNS, the ingress controller, and the core databases that CCX depends on for metadata and orchestration. Now the installation is complete. We have the CCX dependencies installed. We can run kgit pods to see the pod inventory and their status. After a few minutes, we see that all pods have been created. That is the MySQL operator that CCX relies on, including external DNS, the Nginx ingress controller for access, etc. With the CCX dependencies deployed, we can check it using the helm list command. You can see that the dependencies have successfully deployed in the dev namespace. Next, we'll deploy CCX core services. First, let's take a look at the core services Helm chart in the documentation. This is the CCX core services Helm chart, and these are the Helm values. These are the configuration parameters we need to update. The session domain name for the domain we want to use to access our CCX deployments, subdomain, as well as cluster control subdomain, which CCX is built on top of. We'll use the Prometheus hostname for the observability stack that we'll deploy. Another configuration parameter is the cloud secrets. For this demo, I will add the AWS secret I have already created. To enable the deployment of CCX pods and resources on Kubernetes on AWS, there are several other configurations we won't cover in this demo. For detailed information, you can refer to the Helm chart documentation. Let's go back to the terminal. We'll soon copy the CCX core services command. But before that, let me show you the values.yaml configuration that includes the domain name I'm using for this demo. Then just use list. You can then see values.yaml. I'll just show you this configuration using the cat values.yaml command. We'll use the subdomain name yourcloud.dev.s9s.io. After deployment, I'll be able to access CCX and cluster control from these subdomains. This is the Prometheus hostname when deploying the observability stack, plus the AWS secret. Let's run the Helm command to install CCX. It runs in debug mode. It installs the CCX resource from cmon, which is cluster control, the brain that handles the database deployment and orchestration operations. The CCX UI from your admin panel, the end user portal, the billing API for providing billing information to your users, and the authentication services. It takes a few minutes before the installation is done. After a few minutes, you see that the CCX core services installation is complete. At the end, you'll receive some notes with instructions. See the first point listed. Get your admin at getccx.com user password by running the following command. Admin at getccx.com would be the email, and the output of the command would be the password. We'll look at that very soon. The CCX server will be available via this subdomain name, and for cluster control, you'll be able to access it via cc.yourcloud.dev.s9s.io. The next step would be to install the observability stack. But first, let's check that all the pods are running. You can run git pods. You should see all the pods running, including all CCX dependencies and pods. This includes billing, data stores, the CCX UI, the MySQL operator, and the cmon master pod. This handles the deployment of data stores on your data plane. The next step to access the CCX server is to point the ingress host to the subdomain name for that particular ingress host. Run git svc. You can see the Nginx ingress controller load balancer. We need to point the subdomain to the external IP. As demonstrated here, the subdomain is configured to point to the hostname of the load balancer. Now, let's deploy the CCX observability stack. I've already pulled the Helm chart. Next, let's look at something similar to the CCX installation. There's a values.yaml file that you should modify to define your specific deployment requirements. For the observability stack, there are two default values we need to modify. But first, let's go to the monitoring values YAML file. The file was created, so let's cat the file. And don't forget to add a cluster name and a CC host. There are many other configurations, such as Victoria metrics. By default, CCX uses Victoria metrics for gathering metrics, but you can use any Prometheus-based metric server. Let's go ahead and edit this installation. Edit this YAML configuration to include the ingress host name and the name of the cluster where it's running. Use vi monitoring values.yaml to edit the file and add the host. The name of this cluster is k8s-dev-ccx. Before running the Helm install command, it's ideal to create a namespace specifically for this installation for workload separation. So I'll create a monitoring namespace. Then set up kubectl to run against the monitoring namespace. Now we can deploy the CCX observability stack. I will run the command in debug mode using the monitoring values. This takes a few minutes, after which the CCX monitoring stack should be deployed. After that, you will get a note that the user password for Grafana can be obtained from a Kubernetes secret. You can now access the CCX admin panel and the end user portal. Let's head over to the browser and go to the domain name, which is yourcloud.dev.s9s.io. The first thing you need to do once you get the domain name is to accept the self-signed SSL certificate, as this is a fresh installation. After accepting the self-signed SSL certificate, you'll be met with the end user sign up and login interface. But before we log into the end user interface, let me briefly show you one of the admin interfaces. Go to yourcloud.dev.s9s.io/auth/admin. This is the admin login interface. Here you can see the admin login. As mentioned earlier, you can customize this to have your own front end and UI. To get the default admin username and password, let's go back to the terminal. Then, run the get secret command to get the default admin user credentials. Whoops, I was in the wrong namespace. Let me correct that. Now, to the dev namespace. This is the default admin login and password. Let's copy both and insert them into the admin login interface. It will log you in. Now, you'll be able to see the admin interface. Currently, there are no end users and no data stores. Let's look at the end user experience by going to the end user interface and signing up. There's no mail server for this demo, so we'll skip the email confirmation and move on. Here you have the notification. You have successfully completed your account. Enjoy CCX by creating your first data store. This is my email address, and this is the end user interface. As an end user, I can now create my first data store. As mentioned earlier, these are the databases that CCX currently supports: MariaDB, MySQL, Postgres, Redis, and Microsoft SQL Server. For this demo, I'm going to deploy a Postgres 15 data store. Next, select the name and add your tags. Let's create a single node cluster that we can scale both vertically and horizontally later on. As a CSP, you have the flexibility to define various instance types for your end users. You can configure names for each instance type, different CPU and RAM configurations, as well as various volume types. Here is a general purpose volume configuration and an IO optimized volume. I'm going to select the tiny instance type, then I'll choose the general purpose volume for this test. Set your storage size to 80. Your end users have a choice to deploy their instances in a private VPC or publicly. We selected public for this demo. Your users will get an overview of all the configurations before deployment. Click Finish, and the data store deployment will get started. It'll take a few minutes for the data store to deploy. It's currently at 16%. While the data store is being deployed, let's go to the admin user. The admin user interface would see that the user test@email.com is deploying a Postgres streaming database. Here you can see the user we created and their user ID. This is just a simple admin interface. You also have an additional cluster control admin panel that will give you in-depth information on the internals of deployed database clusters. To access the CC interface, go to cc.yourcloud.dev.s9s.io. We can get the password just like the other admin interface from the default secret that was created by CCX. Enter K get secrets -n dev to get secrets in the dev namespace. The CMON credentials secret stores the cluster control credentials by default. You can configure these credentials for the CC login interface, similar to what we did for the admin interface. With the default login and password, you can log into the cluster control admin interface. Grab those credentials here, and then go to the login screen. Enter the CMON user, associated password, and then log in. As an admin, you can see the cluster being created. This gives you more control and a better overview. We'll get back to this while this cluster is being created. Let's go back to the end user interface and explore a few additional functionalities of CCX. After the cluster is deployed, monitoring will be set up by the observability stack that we installed. While that is being set up, let's take a look at the data store. If you recall, we tagged this data store with demo. You can see the other tags created by default: Postgres, version 15, AWS, etc. Now let's look at the nodes. Currently, there's only one node for this data store. We can also see the connection assistant. As an end user, I can create the connection string to connect to the database. This is the default user admin. Here is the particular node I want to connect to. With any technology you use, whether you're building a Java application and you want to connect using JDBC, or building a Go or PHP application, an end user can easily create a connection string to connect to the application. This process is very straightforward. End users don't need to search through documentation. They will receive a connection string and can simply click Reveal Password to grab their password. An end user can get everything they need from the CCX user interface. For example, end users can review events in the Event Viewer tab. This was the task that we created earlier, the database deployment. Here, you can view the query stats. However, since this is a fresh installation with no connections, there is currently no data available. For top queries, these are just default queries that run while the database is being created. You can create more users to access the database and give them certain privileges. The admin user has create DB, create role, inherit, and login privileges. This is the firewall, which allows you to create a trusted source for your database using a specific IP address, which is crucial in preventing unauthorized IP addresses from accessing your database. Under Settings, you'll see the DB parameters, which you can edit. This section also shows you the data store name and allows you to set scheduled maintenance for the data store. Let's go back to the overview. Monitoring is still being set up. It will only take a few more minutes. While we wait, let's access the admin interface through cluster control. You can see that the Postgres cluster has been deployed. As an admin, you can see that monitoring is still being configured for this cluster. You can see the jobs. A default backup job is currently scheduled for the CMON user. As an admin, you can see all these for your users' database clusters. You can also see DB growth over time. You can view database variables, which can also be edited. Cluster control provides enhanced control and management functionality over a database cluster. If you've used cluster control in the past, you'll already have some understanding of this. And if you haven't, you can review our in-depth documentation at docs.severalnines.com. Another important feature is that, as an admin, you can create operational reports for your databases. You can select the user's cluster. This is the first cluster in the ID. You can choose the type of report you want to create. For example, if your user reports downtime issues, you might want to investigate what happened. Create the database availability report and set the date range. You can also set the email address to send this report to. Click Create to generate the report, and then you can view the report by clicking View. You can see how long this database has been up. It has 100% availability with 0 minutes of downtime. There are other reports you can also create. Beyond availability reports, you can create backup, upgrade, database growth, default system reports, and more. Let's go back to the end user interface. We have monitoring set up now, and you can look at the system metrics. You can see the CPU and RAM usage. This is a new database, so nothing significant has arisen yet. You can also see database-specific metrics, such as select queries, input queries, and update queries. And you can view this data over different time periods, 1 day, 1 week, etc. As a CSP, you can create various graphs using Grafana to offer more insights for your end users. Let's quickly look at scaling. With CCX, end users can dynamically scale the database. Use the Edit Storage option to scale your database storage. The database storage capacity is currently set to 80 gigabytes. We can scale to a maximum storage size. For this demo, let's scale to 100 gigabytes. You can see an event running, updating the volume to 100 gigabytes. Aside from scaling the storage, you can also scale the nodes by adding more nodes. You will see a job in progress, so please wait before making any further changes. Once the update is complete, you can see that the storage is now 100 gigabytes. Now that that job is done, let's go ahead and scale the nodes. As you can see here, you can scale up to 5 nodes, but for today's example, let's scale up to 3. Select Availability Zone, instance size for the new node, and then do the same for the second node. And save. The nodes will begin to deploy. As a CSP, you can monitor what's happening, generate operational reports, and assist your users if anything goes wrong. Before we wrap up, let's check the pods again quickly. Enter k git pods-n dev to see all the running pods. Note that when new versions of CCX are launched, you can always upgrade and make further changes. Now let's quickly talk about the support you'll have in case you get stuck at any stage. We pride ourselves on our support. As a CSP, you are entitled to a 1-hour response time SLA. However, our support team has an average response time of approximately 4 minutes. That's it for now. Thank you for watching this demo of CCX for cloud service providers. Grow your cloud customer base with CCX for CSPs. Get started today at info.severalnines.com/CCX for CSP.